Hello students! Have you watched the last video? It's pretty clear, right? Okay, I want us to continue working with some guided exercises. Let's do some together because I want to be very clear for you. For example, I want us to do carbon together. Let's do it in order. Remember which is the step number 1? Right, we need to write the chemical symbol. Chemical symbol for carbon is C. Now, next step is find the number of valence electrons. Do you remember in which family or in which group can we find carbon? Look for it in the periodic table. Yes, carbon is located in 4A group. It means it has 4 valence electrons. You need to remember this. The number of the group where the element is located equals the number of valence electrons you will need for drawing Lewis structure. So, let's draw, this is step number 3. Let's draw valence electrons on each side of the imaginary cross we were talking before. I will write 1 valence electron here, another here, 3 and 4. Remember to draw 1 at a time and 1 on each side of this cross. This will be the complete Lewis structure for 1 atom of carbon. What about lithium? Let's do it together. Again, step number 1, write the symbol of the element. Step number 2, look in the periodic table in which group lithium is located. It is in group 1A. It means it has 1 valence electron. Where should I place 1 valence electron? You know, it doesn't really matter if you write it up here, for example, or maybe you decide to write it somewhere else in here, or maybe you want to draw this down here. It doesn't matter. You can choose the side where you are going to begin placing these dots or these electrons. Krypton is a good one. Let's do the first step together. Write the chemical symbol. Number 2, you know, I want you to listen to these instructions and pause the video and try to do step number 2 and 3 by yourself. Try to do it. We already done step number 1, which is writing the chemical symbol. I want you to find the group where krypton is located, and I want you to draw the valence electrons. Do it and pause it for a while. Ready? Have you done this? It's krypton, actually. Let's see if this is what you got. Krypton is in a 8A group. It means it has 8 valence electrons. You should have done something like this. Let's say if you begin from the top, you would have written something like this. 1, 2, 3, 4, 5, 6, 7, and 8. And those are the 8 valence electrons for krypton. If you remember, this is a noble gas, and noble gases are not chemically reactive. Why they are not reactive? You can see with this drawing, you can imagine an explanation. There is no empty space for an extra electron coming from other element. Did you see that? This octet is complete. Let's do oxygen together now. Do it by yourself. Pause the video again and do it by yourself. Have you done this? Okay, let's try to review it. First, I write the symbol in the center of my page. And now I know that it is in the 6A family, so I need to draw 6 valence electrons. Now I will begin somewhere else. 1, 2, 3, 4, 5, and 6. Can you see some empty spaces here where probably some electrons from other elements can join? Of course, we have an empty space here and we have an empty space here too. So what happened with this empty space? Well, at this point we have been learning elements by their own, not combining. And you know, elements can exist in pure nature as elements, but the majority exist in a combined state. That's why the octet rule says that atoms can combine. They actually lose or gain or share valence electrons. And they have a configuration as a noble gas, having 8 electrons in their outermost energy level, and that's the way they become stable. Do you remember just the krypton we did? It had 8 valence electrons. Yes, but now it's the time to do Lewis dot structures for compounds, not only for elements. Let's do it with compounds. First example, very, very easy. These are 2 atoms together. It's no longer a single and alone element. And let's follow the same steps. Step number 1, write the symbols. Okay, now we have 2 hydrogens. Do you remember that this little number in here, which you know should be actually subscript? This number in here tells us how many atoms of this symbol are included in the formula. So in this case, we have 2 atoms of hydrogen. That's why I wrote 2H from hydrogen. Step number 2, where is hydrogen located? In group 1A. It means it has 1 valence electron each. So, where am I going to write this valence electron? I will write the one from this hydrogen in here. And what about the other hydrogen? Well, here is the other hydrogen with its own valence electron. You see, we have reached the important part. These 2 electrons in here are those which composed the chemical bond. As you can see, each bond is composed of 2 electrons. And finally, we can draw a line between them. And this bond, this line, means there are 2 electrons in there. In this case, 1 electron coming from one hydrogen and the other electron coming from another hydrogen. Let's draw water together. You know water has a subscript 2, right? So maybe it is time to set the 4th step for drawing Lewis structure. The fourth step, sometimes it helps. You need to write the most electronegative element in the center. So from hydrogen and oxygen, which one is the most electronegative? It is oxygen, very good. So I will draw oxygen first. Please tell me, how many electrons does oxygen have? Very good. It is in the 6th group in the periodic table, so it has 6. I will write 1, 2, 3, 4, 5, 6. These are from oxygen. Now, can you see where do you find 2 empty spaces in this structure? Yes, very good. There is an empty space here, and there is another empty space here. So guess what? We need to draw hydrogen in these 2 empty spaces. So let me grab a different color for hydrogen. I will write hydrogen here with 1 valence electron. Remember that it is in group 1. That's why I write 1. And the other hydrogen is here with its valence electron. How many bonds can you see here? Of course, there are 2 bonds. This is 1 bond, and this is the second one. How would you write this with lines? You will write hydrogen, 1 bond, oxygen, 1 bond, and the other hydrogen. These lone pairs of electrons here are important. We will talk about them later. They are not bonding because there isn't any atom over here to bond with, but they do exist. I know your question now. You will be asking why, if my final structure was something like this. It is correct too. Or what if I begin in other side and my final structure is something like this? It is correct again. So, the step number 5 for drawing Lewis structure will be fill the empty spaces with the other elements of the compounds. If you see, we filled the 2 empty spaces of oxygen with 1 atom of hydrogen in each side.